Pre-calc review, number 1, chapter 9. Given f of x is x squared plus 2x plus 1, what is the average rate of change from 3 to 3 plus h? So we want to always show f of 3 plus h minus f of 3 over 3 plus h minus 3, or y minus y over x minus x. And let's put them in. If I put in 3 plus h wherever x is, 3 plus h squared, 2 times 3 plus h plus 1, minus, if I put in 3 squared minus 2 times plus 2 times 3 plus 1 over, I can simplify this right away to just h, but let's not lose that denominator. I'm going to expand this. I could use my box. 9 plus 6h plus h squared plus 6, 2 times 3, plus 2h plus 1 minus, and this is going to end up being 9 plus 6 plus 1, which should be 16, all over h. Let's start looking for some like terms. 9 plus 6 plus 1 minus 16 is all going to go to 0. 6h plus 2h is going to go to 8h, and I've still got my h squared all over h. Can we simplify a little more? I think I can factor an h out of the numerator. H times, the 0 can go away, 8 plus h over the denominator. And now I can simplify away this h. So my average rate of change for this function from 3 to 3 plus h is going to be 8 plus h. Fantastic. Part 2 says, what would the IROC be at 3? So I found my average rate of change for 3 to 3 plus h. My IROC definition is, that's the limit as h goes to 0 of my average rate of change. So if h is 0, my instant rate of change at 3 will be 8. And understanding in this problem that average rate of change has that h in it, and my instant rate of change is when I put the 0 in for h. And because I have my instant rate of change of 8, now I can find the equation of the line tangent to the graph at x equals 3. When we say tangent line, we always want to write y equals mx minus x1 plus y1, and we want to start filling it in. I know that my slope is my instant rate of change, so that's going to be 8. Now, what is my point? My x value is 3 because it's at x equals 3. I need to find my y value by putting the 3 back in here. We actually put that in the original function, and when I put 3 in, I got 3 squared plus 6 plus 1, which was 16. So now I could check on my calculator. If I graphed our parabola, should have a nice little bounce at x equals -1. And then if I graph this guy, 3 comma 16 way up here, should just touch there. Perfect, nice. Probably a little steeper than that, but they should definitely just have the point of tangency at 3 comma 16. Great.